2. The scientific revolution. All the major 17th century breakthroughs in mathematics, astronomy, physics, chemistry, and biology happened in Western Europe. The difference with earlier advances in science was the realization that through experiment and measurement, nature could not only be understood, but manipulated and even mastered.
This is one of the biggest falsities ever made on Earth before by a human being, especially when they're talking about through experiment, measurement, and the fact that nature could be manipulated. These were core, and I'm sure if you've already seen my channel, you know these were core things in the Islamic Golden Age. Ibn al-Haytham would be a good example, who invented a type of scientific method, which, by the way, scientific methods existed in several parts of the world, including India, Greece, and so forth, and other places. Ibn al-Haytham's scientific method was very similar to the modern scientific method and consisted of a repeating cycle of observation, hypothesis, experiment, and the need for independent verification. Now, this is just Ibn al-Haytham. We could talk about the other people like Al-Jahiz and all these other people, and the fact that they believed that there was solutions to the world. All you had to do was understand nature. This was not just something that was floating in the air. This was things that were being pushed at the time of the Islamic Golden Age. But more important than this is the fact that the Islamic Golden Age is a direct, not an indirect, a direct link to the scientific revolutions or scientific achievements of the 1700s. That without the Golden Age, you will not get the things that happened in the 1700s. In fact, some of them in the 1700s were mere repetitions of what had already happened in the Golden Age. Take people like Isaac Newton, for example. Take people like, just take almost all of these Europeans at the time. You will see that they get supplanted by other people, evolution.
The model for universities in many ways were the early universities in Islam. The notion of having hostels for students. As one prominent scholar of Islam said, during the Dark Ages, if you were up on another planet and you looked down, the West was invisible. It would have been the Islamic world that stood out. And the idea that during that period, you had a fluorescence in terms of the areas of philosophy, medicine, algebra, etc. And then that was carried over into the West. The same thing happens when you look at areas of medicine and science and technology. And a lot of that is just beginning, I think, at a popular level to surface right now.
One of your colleagues at Georgetown actually told me once that even Thomas Jefferson was influenced by John Locke, who was influenced by the Muslim philosopher Ibn Tufayl.
And a new centre of learning, the House of Wisdom, before the end of the 8th century, successive Arab caliphs employed the best scholars money could buy. The late American professor of history, Carl Boyer, writing in his History of Mathematics, makes the point that the Arabic miracle lies not so much in the rapidity with which the political empire rose, as in the alacrity with which, their tastes aroused, the Arabs absorbed the learning of their neighbours. Not least because of its practical everyday applications, mathematics has always been of central importance in all civilizations. But during the Islamic Golden Age, we saw astonishing advances in all fields of maths, not least algebra. To better illustrate this, I'm going to talk about a man whose very name is at the heart of algebra and algebraic calculations. He is Muhammad ibn Musa al-Khwarizmi. And the word algebra comes from the title of one of his books, the compendious book on calculation by completion and balancing. The compendious book on calculation by completion and balancing would be translated from Arabic into Latin twice during the 12th century by two of the most important translators of their day, the Italian Gerard of Cremona and the Englishman Robert of Chester. It was a revelation to educated Europeans, and every well-stocked library would have had a copy. Al-Khwarizmi,
most famous work, Kitab al-Manazir, or the Book of Optics. In this work, Al-Haytham used mathematics and experimental observations to examine the human visual system more systematically than anyone before him or after him until the 19th century. According to Lindgren, Alhazen leveled a devastating attack at prevailing optical theories and formulated a grand and viable alternative. Ibn al-Haytham wrote on subjects such as visibility, the perception of color, the effect of bright lights on the eye, how light enters the eye, and more. The experiments of Ibn al-Haytham had a profound influence on European scientists, with his experiments being used by Roger Bacon and Johannes Kepler's, among others. The Book of Optics was written in 7 books in the 11th century, but today, only 2 Arabic copies containing books 1 through 3 exist.
Books that still exist today show that not only were they dealing with these scientific dilemmas, but they were dealing with all kinds of dilemmas to try and understand the world. You get the Kitab al-Musica al-Kabir, which is the big book of music written by Abu Nasr Muhammad ibn Muhammad, and several other things like the Book of Animals written by Al-Jahiz, or the Book of Optics, or the Book of, like, almost anything you could find a book on several subjects, books on laws, books on anything, because to understand the world, the Book of Medicine, how could I forget that? You could find them in the ancient Islamic because they were so interested in understanding the world. They even came to conclusions about elements and atoms and all this other stuff because of their great want to research and divulge and go through something called, and I forgot the word in Islam, but skepticism. And this isn't merely the olden days of Europe that copied. If we look here, we have Copernicus's drawing right here, and you can see its similarities to Al-Tusi, which is a Islamic scholar. And you can see that not only are they similar, but the places where the alphabets are put at almost the exact same place, making it obvious that there is a direct copy between Copernicus's work and Tusi's work.